Speak up, go to the mic.
Does it count if you only access the meeting through the website rather than scan the QR code? Does it count as signing the blue sheet?
I believe if you sign into the meeting, you're counted in the blue sheet. There's also a QR code in the foyer outside. And so should you fail to sign into the meeting, you could
Unfortunately,
scan the
it's right
QR
between
code
the doors
outside.
of 302 and 301, so you don't really know which one you're signing into.
We are in 302. All right, well, we're at start time, we're a little thereafter. So let's get underway. Welcome to the COSE Working Group meeting on this Monday in Yokohama. I am Mike Jones. You can also see my co-chair, Ivo, who will be helping to chair the meeting from Europe. Thank you for staying up into the ridiculous middle of the night to be here. At every IETF session, you will see the note well, which says that by agreeing to participate, you're letting us use the materials that you provide or not. For more details, read the note well and associated materials. As I said informally beforehand, be sure to sign into the Meet Echo Lite if you're in the room. Those of you who are remote must have already signed in or you wouldn't be hearing me. Make sure your audio and video are off unless you're chairing or presenting, and use of a headset is recommended if you're presenting. There's a set of resources, all which can be found off of the meeting site. Now, before we formally started, Gary graciously volunteered to take notes. I would like at least one other person who is not a presenter to also tag team in collaborative note-taking. Can I get a volunteer to do that? Thank you, Mr. Russ Housley. Unlike the last few IETFs, the chairs asked for 2 hours. Before, we were running a dog and pony show, barely having time to get abbreviated versions of presentations. This time we have 2 hours and we have fully filled it. So this is a copy of the agenda, which is also posted in the data tracker. This is roughly the first hour. This is the second hour. I'm happy to report that presentations have been uploaded for each agenda item. First question, is there any other thing we know in advance that we want to discuss in our last 10 minutes? I recognize Ori Steele.
The RATS group had asked for some time.
Speak louder.
The RATS group had asked for some time in our group to discuss the plus CWT structured suffix. They have an item that would like to use plus CWT in a similar way to plus JWT. So I don't think it made it onto our official agenda, but I would like to have some time to discuss it if it's possible.
We can do that. Ori, when you sit, can you put that in the chat for the record?
Yes.
Thank you. I recognize Michael Prorock.
Thank you, Michael Jones. Michael Prorock here. Did want, if there are about 2 minutes at the end just to see if there's a raise of hands of folks interested possibly in working on ASCON for COSE, since we now have some embedded lighter weight cryptography options as opposed to AES for embedded devices.
Thank you, Mike. Please put that in the chat. All right, I'll give a moment of status of documents in the working group that have advanced past working group last call, which is customary at this point in the meeting. I'm happy to report that we have 2 new RFCs to our credit since we last met our heroes. One is countersignatures, RFC 9338. And the other is the X509 certificate header parameters, RFC 9360. Furthermore, a draft that we discussed last time, the AES, CTR, and CBC, completed working group last call and has been submitted for publication. It's currently under IESG consideration. We will wait for AD and IESG feedback and go through the process as we do. Thank you, Russ Housley, for advancing that. All right, with that, let's move on to our agenda. Mike Prorock, I believe you're next. I am going to attempt to share your slide deck. Voila.
Perfect.
And I believe you verbally tell me when to advance the slides.
That works for me. So thanks very much, all. Good to see everyone. Hopefully Mike's coming through okay, because I can't hear it back here. So just yell at me if it's not.
Raise it if you can.
How about now? No. Is the mic on? Give it a second now. Now we're actually picking up. That on-off switch actually does something. So thanks all. Hello. Glad to see you all over here in Japan. We're going to be talking today about post-quantum signatures and how they apply to COSE and HOSE. This is follow-on work from a draft that described 3 methods, which is why we now see 3 items based on 115 here. So next slide, please. So wanted to first just set the basis, and obviously open to taking any questions on this stuff, but I think at this point now, probably 3 or 4 IETFs into discussing this, most folks are aware that there are certain items that are potentially broken, or at least hypothetically broken with the introduction of quantum computing. In particular, things that rely on large factoring type problems. So one of the things here is that NIST has gone through and announced some candidates that will be standardized, particularly for the signature side of things, and that's what we're looking at today. And there's really 2 types of things from a math standpoint that are built into the signatures that we'll be looking at. One is hash-based, and that's Sphinx, Sphinx Plus actually. And then 2 have some elements of lattices and fun stuff like that in there. So it's really taking advantage of some different mathematical structures in order to get good signature approximations that don't fall potential victim to quantum computing style attacks and machine learning attacks. So next line. So key goals here for this set of drafts is to make sure that Sphinx Plus, Falcon, and dilithium, so the leading candidates for post-quantum digital signatures from NIST, are well described for COSE and HOSE usage. They have good usage in lots of different things, both within IETF and then elsewhere outside of IETF relying on this. I am participant in the verifiable credential working group over at W3C, as well as the DID working groups over time, unfortunately. And as a result of that, would like to be able to point to these from normal cryptography rather than crazy things. We definitely want a clean upgrade path so that as we are looking at things like crypto agility and having cutovers from one signature method, say Edwards curves or RSA, things like that, we want to be able to jump over into post-quantum methods where appropriate. We do also want to provide a good model for anticipation of potential exploits in emerging tech, and not necessarily assume that even these three methods that have been very well studied and reviewed and hammered on are perfect, right? So, and then the other key thing, and this is, I think, especially apparent if you look at the way we've looked at KTY and ALG in particular from the Jose side, is that we want to set a path for other post-quantum algorithms that are using similar mathematical approaches and families. And then obviously we want to make sure that we can get IANA registrations in place for parameterization, since parameterization with these algorithms is key. Next slide, please. So what's new with post-quantum stuff compared to what we are used to with digital signatures to date? And probably the key thing is that, you know, and only some pun intended there, is that the keys and signature sizes tend to be significantly larger than what we're used to dealing with traditional digital signature approaches. This does not necessarily mean, however, that verification times, right, are impacted in a negative way. In many cases, we're seeing very, very efficient verification times, despite adding a good degree of complexity and strength in both the key and the signature size. There is, however, some complexity, especially on the hash-based side of things, which if you go in and read the Sphinx draft, you'll see, because we have focused on a couple of sets there. But the parameterization could get a little crazy there, especially with hash-based approaches to signatures. So because you can get into strange combinations of SHA-2 and, you know, shake and all sorts of other fun stuff there. So we need to be extremely clear about, especially from a Jose and a COSE standpoint, exactly what parameters are in use with which signature schemes so that there's no confusion and we don't get into future attacks or vulnerabilities based on someone incorrectly specifying what parameter set or possibly trying to load the wrong parameter set with particular key materials or signatures. Next slide. So since 115, we have split, based on the feedback of the group, the initial post-quantum signatures draft into 3 drafts. There is now a draft for dilithium, there's a draft for Falcon, and a draft for Sphinx Plus. And I realized I put a typo in these slides. That's actually 0 zeros on all of those. They are replacing the 0-1 draft for post-quantum signatures. So did want to note that typo on the slide. With Sphinx Plus, even though that it is typically referred to capitalized Sphinx with the plus sign afterwards, in practice that can be really problematic when identifying different types of things, right? Especially in media types, etc. So we have opted to go ahead and spell out plus, right? So Sphinx dash plus, the word plus. Would love feedback if for some reason someone thinks that's a bad idea and we should include the plus sign, but just in case. So do want a note on that feedback there. Next slide.
Speaking as an individual, I think that's a good call.
Thank you, Mr. Jones. So there's some help wanted here. And this, I think, is really where we get into the fun Q&A and may eat up the rest of our time as this slide and the next slide, which is naming is hard. And Ilari noted on the list, I think maybe even this morning or certainly yesterday, that he hates the KTYs that we have selected. We don't particularly like them either. We initially started with one KTY and just saying, nope, we're going to have a PQC, right, for generalized post-quantum key types. In practice, we also knew that was not necessarily good either. So, and we'll get into the decision that was made there in just a little bit. We need to figure out where we finish with this, right? And in particular, because the combination of KTY and then ALG in order to show exactly what parameters are in use to avoid potential security issues is really key with these algorithms. We want to make sure that we do this right before it is finalized. The other one is that we need eyes on test vectors. In fact, I found as I was preparing these 00 drafts, a nice little bug in even in our own test vector generation code. Not looking at anyone in the audience right now. And both of us had missed it right up until I was preparing a 00 and had to manually correct it. So we do need eyes in. There are some good implementations out there of all of these algorithms, good independent implementations. Need to cross-check this stuff. And then obviously waiting on feedback from NIST on parameter set finalization and feedback. And I think that's what would prevent a final, let's move this along the process at the end of the day, because we're not sure exactly what those parameters are going to be at the end of the day. There could be some minor tweaks still. Next slide.
Actually, there's two people in the queue that I'm going to recognize. First is Mike Unsworth.
Mike Unsworth. To your point about Sphinx having way too many parameter sets, I just want to put on the record here, in November, NIST, Dustin Moody put out a call, does anyone want parameter sets that are smaller than the current ones that can do less than 2 to the 64 lifetime signatures? Seems like a thing this working group might want to have an opinion on, although it makes more parameters, not less.
Yeah, I agree with that. I think that was a good call. And I do think everyone is aware that there is some complexity. Scott over at CFRG is a great one to go reference if you want to look at some of the crazy combinations we can get into with Sphinx Plus. He's run some great math on what those possible combinations are, and it's quite amazing. So that is definitely something that when we get into the PQIP or whatever we're calling it now, the new post-quantum group that many of us are taking part in, we will certainly be looking to feedback from that group before going to, or as part of a working group last call, et cetera.
I recognize John Bruce Madsen.
Yeah, so John from Ericsson. Is the goal here to wait until NIST has standardized? I think that's two different approaches. TLS have some Kyber draft, which I would not be super interested in. I would be super interested in the standard, but I'm not against pre-version. But I think if it's pre-version, it should probably not be standard track, then it's probably be information. You say we should wait about NIST, but all the tests, I would say it's very likely that all of the NIST final standards will have significant changes, definitely affecting test vectors. So talking about test vectors for these are way too early. Yeah. So I don't know, what does the draft want to do? Do you want to standardize something quick that is like pre-standardization, informational, or wait?
That is an excellent question. And I think I have heard multiple divided opinions on this. Personally, I am in the camp of test vectors are a bit early on this draft. Seeing some thumbs up in the room here. But there are certain things like dilithium where we're not likely to see huge changes. And this was part of the reason to split the drafts apart, is that some of these things may be ready before others. So it's just something to consider. We will defer to the guidance of experts in the field while providing our own opinion on where things should stand.
I recognize Karsten Bormann.
Yeah, Carsten Bormann. We want to standardize something that is based on the actual standards that NIST puts out, period. I don't think anybody in this room disagrees. Is anybody disagreeing? Okay. However, we cannot just wait until NIST is done and then start writing our drafts. So we have to start writing them now so we can have a reasonable finalization period of a couple of months when NIST is done. So I think this needs to be very, very clear in the document. We need to choose names for registering provisional stuff that clearly identify things as provisional. But we do want to have things like test vectors so we can make sure that people actually get all the other parts of the implementation right until the final verdict from NIST arrives.
Yeah, Karsten, I think that's exactly where my personal feelings on the matter fall, to the point where we've been testing with like open quantum safe as well as with dilithium with our own implementation, because we have to validate some of this stuff in the real world to find out what problems are going to happen over the wire. And I am a big fan personally of provisionally getting some of these things locked up so that we know what way things are going, and then make that final determination after the standardization occurs. But that's a personal opinion, but I agree with you on this.
Yeah, and I'm saying it should not stay
Yeah.
a personal opinion. It should be the course of action we agree on as
Yeah.
the work.
Okay, I recognize Russ Housley, and then I'm going to close the queue on this discussion and advance the slides.
Hi, Russ Housley. So there's at least 3 documents about dilithium, 3 documents about Sphinx Plus, 3 documents about Falcon, and they're in 3 different working groups. And so we need to make sure the authors are talking to each other. The biggest disconnect seems to be how much goes in the identifier and how much goes in the parameters. Let's just make the split the same across those so that one library could support all 3. That's all I'm going to plead for.
Yeah, Russ, I think that's a great point. And I think this is where the group we formed or voted to form at IETF 115 was very, very helpful because in a couple of cases, there wasn't 100% communication. But if we do notice on this draft, there's a reason Micah, Osborne and Christine are all both drafts. And we meet very regular, right, along with some other experts from various agencies looking at fun ways to break this stuff apart and how do we, find vulnerabilities. So yes, agree on very open communication and seeking after consensus across all the groups working on this stuff. So moving on topic wise, KTY plus ALG. And I think this goes as a direct follow on from what Russ was just bringing up here, which is we probably need to identify the families very clearly and then the parameterization after that. And I know there has been some disagreement. There have been suggestions of using a single parameter type, et cetera. We are looking for direct feedback, right? There have been some options brought up like using OKP for everything. There have been options like, hey, let's take, the parameters for a lattice and shove them into the CRV parameter, which not only is incorrect from the math side, could be extremely confusing to someone with an implementation side. So we want to avoid those kinds of problems, right? Biggest thing we're looking for and kind of how we went about things was to say, what family of problem is this algorithm based on? Let's go through and identify a KTY for that, and then the actual parameter sets based on the specific algorithm in this case, because there are other things, right? In the case of ntrue, for instance, yes, we have signatures that have come out of that world. We also have things like chems that have come out of that world. So we're setting a path in order to get some reuse there. Same thing with hash-based approaches, right? There are multiple hash-based approaches to signatures. We could see future hash-based approaches there. Same thing also with the ring learning with errors side of things.
So I'm going to speak as an individual. When we did key type and ALG in JWK, which is RFC 7517, the design criteria we used for having different key types is if the keys were syntactically different. Obviously, if you have a different syntax, you need different parameters to represent the keys. Different choices could be made, but again, just as an individual, in the spirit of what was done before, I would try to follow that guidance if you think it fits the use cases.
So Mike, just to a question back on that. So are we reading that correctly when saying, hey, if there's a syntax of a type of key because it's this certain type of lattice problem, even if we encode that as some, hex or something else, that we should treat that as a unique key type because of the problem set involved? Is that correct? Or is it more about the formatting and the serialization side of the keys?
If you need different parameters to represent the key, it obviously has to be a different key type. Choices could be made within that key type. And I'm not going to belabor the point here, but
Okay.
that's just a point of history.
That's helpful because in this case, Entrue has its own class of parameter sets, right? Any of the Falcon-based stuff, especially. Same thing with Sphinx Plus. Same thing with dilithium, where they're very distinct types of parameters.
I recognize Ori Steele.
Ori Steele. So in the recent discussion on the list, Ilari made the comment that all three of the post-quantum formats, key formats we've been looking at have the same sort of structure as the ED25519 EDSA keys in terms of a key type, alg, an X, and a D parameter. So I think if your syntax comment is about, what are the unique members you need in a JSON object to represent the key, that email thread is enlightening to some degree. That's it.
All right. Thank you. I recognize Mike Unsworth.
Mike Unsworth, this might be a topic to bump to PQIP, but encodings and the QSC Unikeys drafts is another point for coordination. Are you taking those encodings? Do you have your own encodings? What are we doing with those
Yeah,
drafts?
we because of the Jose side, right, there's base 64 URL in the mix on that front. We are, however, trying to align with that. That's one of the reasons we've got folks talking on both sides there.
Okay, am I on the right slide, or do you want me to advance?
We are fine to advance. And I believe the advance is, let's now just get into the next steps, which is we are awaiting NIST. We will continue to await NIST and would love feedback from them and further feedback from them, but I think they're in a good place here. We do want to get to a final place of KTY now, right? Let's get that optimized as a group. And now it's really, let's go in and just polish the language, the editorial side. The basic structure of these and how to use these with both Jose and COSE is working, but we do need to get some preliminary reservations on things, obviously, for COSE for better interop type testing, and looking for general guidance from the group since I'm new to this and an idiot generally. So resources if you need them, big old GitHub. If you haven't seen the NIST stuff, it's out there, and there's some direct links at the bottom to the signature suites. So if there's any questions or comments back from the broader group, would love to hear them.
Would anybody like to join the queue? All right. Thank you, Mike. Next up, we have Tobias Slicker talking about BLS key representations.
Thanks, Mike. Next slide. So just a basic overview for those unfamiliar with this draft is it defines and registers the required parameters with IANA for the cryptographic representation of a elliptic curve known as BLS in the two possible curve constructions for both the COSE key and JWK format. Next slide. This is just a little bit of rationale for what supports this draft, which is there are multiple algorithms that are making use of this curve at the moment, the BLS signatures, CFRG draft, and the BBS signature scheme with the draft 02 that was recently published. And a status on this, it's basically, it's a simple draft in terms of the registration. It was adopted in July of 2022 into this working group, and we published the draft 02 recently, which updates the JWK based examples, the COSE key based examples, and namely we shifted to a uncompressed public key representation that I wanted to briefly ask the working group about today in terms of direction beyond here. So next slide. Effectively, the predominant point encoding method that's being used generally for point encoding, but also obviously for public keys in this algorithm, in both signature schemes that effectively use this curve is a format that's informally defined by the Zcash community, and it's referenced in Appendix C of pairing-friendly curves. However, the curve, the encoding is curve specific to BLS 12381 rather than being generalized, and there's no other known compressed point encoding method for the BLS curves that's currently in use. So effectively, next slide. It leads us to kind of two options. At the moment, we've sort of moved, well, halfway to moved to this position, which is using an uncompressed public key representation that effectively has both the X and Y coordinates in an uncompressed form, similar to elliptic curve key types used in COSE and JWK today. And effectively, that's easy to define because you're largely following the guidance around elliptic curve, public key representation in uncompressed forms. The notable downside to this is that it's effectively a less efficient public key representation. So there is a trade-off there. Or option two is pursuing a compressed public key representation, effectively using OKP, and finding a suitable definition for a point encoding method that's defined on effectively these two links here, SEC1, which is often referenced, and there's also a relevant draft, I believe, around alternative curve representations that's referenced too, that has a appendix on suitable point encoding methods that we think could be used. So the public key representation would effectively have the compressed point expressed in the X parameter with a key type of OKP. The pros is it's a much more efficient public key in terms of size. The con is that it would be more complex, obviously, to define and involve at least a slightly new point encoding method.
I recognize Ori Steele.
Ori Steele, similar to the comment Russ made before, if this curve is being used in non-HOSE or non-COSE environments, have they encountered this issue? Do they use the uncompressed form? Is there a reason to accept the larger key size to be more compatible with existing libraries? Or can we be the trendsetters and get everyone to use the nice compressed representation?
Yeah. No, quite the opposite, really. Usages of BLS, of keys and schemes that make use of the BLS curves opt to use the compressed form. It's the Zcash form, though, and the current definition of it is effectively very specific to BLS 12381. It is a slight, I will note that it is a slight variation on SEC1. It is loosely based on that. Basically, it's the X coordinate with a bit that tells you whether or not it's the identity point, another bit that tells you the signed, whether or not the Y coordinate is signed, and one more bit that forgetting that expresses another attribute about the expanded public key. And collectively, that information allows you to decompress the representation.
I recognize John Pruce-Matson.
Hi, John from Ericsson. My understanding is that there's currently no algorithms where these keys can be used. I think it would make a lot of sense to also standardize the BLS signature algorithm or some other pairing-based signature with 48-bit signature. I think that would be a great fit for group OSCOR, which is standardized in the core working group.
Thanks, John. So just to respond to that comment, there are two active drafts standardizing algorithms currently at the CFRG. I'm the one of the authors on a group signature scheme known as BBS signatures that uses the BLS 12381 curve in one of the cipher suites, and the BLS signatures draft that's also at the CFRG. But some of the features of those schemes means that using COSE and HOSE as a cryptographic representation format for those signatures is slightly different because they have different features, right? Group signatures and blind signatures operate slightly differently to conventional signatures, and that is also the subject of some of the work going on in the newly recharted HOSE working group around what's known as JSON Web Proof.
Yeah, but I think just the BLS, non-groups BLS signature just for the size, I guess that's a possibility. That I think would make sense and would be very possible. No group signature, nothing
Right.
extra, just
Right.
the size, 48 bytes. Yep.
Yeah, okay, understood.
I'm going to speak as an individual again. It seems to be my role to talk about the history of key types. A decade ago, when we were defining the EC key type, there was a patent that was then current on compressed key representations. That did influence our choice of having the X and the Y. That patent has expired. Not telling you what to do, but there was a reason we did that then, and there's a reason we might not do it now.
Thanks, Mike. And with that, that's really, oh, sorry.
I recognize Ori Steele once again.
So the comment about a simple signature scheme to go along with the simple key representation that's definitely a thought I had when I first read the draft, because to just define a key type, especially in HOSE, I'm looking for what's the pairing to the ALG, at least one ALG, right? So I'm sympathetic to the argument around at least one ALG.
Michael Prorock.
Yeah, I get very nervous when I see things like KTY on their own without an ALG, because parameters sometimes change in unexpected ways right down the line. There's also, from a practical implementation side, right? It's very easy for a library to be trimmed down to just supporting certain key types and families that have been well reviewed for a certain thread area, and then have other cases where you may want to include everything under the sun, right? And for those kinds of deployment scenarios, if you're having to switch off the ALG side and get all this intertwined code and things like that, it can make things a little bit ugly. You don't have that really clean dividing point, and you can wind up in these confused scenarios where a well-intentioned developer thinks that they're going down a certain path, ends up bringing in something that may be called curve of some kind, but might actually not be the type of curve or polynomial or lattice that you're actually looking at, and then thereby introduce a bug. And those are the kinds of things that would be very helpful to prevent even potential accidents from a developer side down the line.
John.
Yeah, I think in general we should move away from expressing key types with a lot of different parameters. I think we should try to move to that it's a byte string, and that's like all the encoding is inside that byte string. But I don't know the legacy interop with it.
Would anybody else like to join the queue? All right, with that, we're going to switch presentations, but not presenters. We will now move to the CWT claims in headers draft. And as a point of order, I now recuse myself from chairing this portion of the meeting because I am a co-author on this. Eva will chair during this presentation.
Next slide. So this is just a brief intro. Effectively, it defines a header parameter to enable the usage of CWT claims in COSE headers in general. We encapsulate this with a single new header parameter because the namespace, the COSE header namespace and the CWT namespaces are effectively separate IANA registries. So we encapsulate inside a new parameter. Next slide, please. A bit of the rationale on why we aim to do this. There are several use cases where it's useful to be able to use existing registered CWT claims in a COSE header instead of just in the payload. For example, unencrypted claims such as the issuer to facilitate identifying perhaps how the CWT is encrypted or the payload is encrypted and facilitate decryption, and also including claims when the payload itself is in a CWT. So say you're signing a detached payload, but you want to be able to use the issuer field to communicate who the issuer or the signer of that structure is, even though the payload itself is in a CWT. So this addresses those use cases. And it's also notable that JWT had a similar mechanism here that permitted the usage of JWT claims in headers. And this is effectively adding that feature in equivalently for the usage with CWTs. So the status is it's a pretty simple draft. It was adopted by the working group in July 2022, and we've just published draft 3 with a couple of minor changes. We added a basic CDDL description for the value type of this header. We'd appreciate review on that. And we've clarified treatment of the claim in protected versus unprotected header usages. And next slide. And really for next steps, I think might hand over to my co-editor here, Mike.
So I will say again, as an individual, when we last met our heroes at IETF115, there were a couple outstanding requests from the working group that they wanted us to do before working group last call. On the previous slide, my co-author talked about us doing those things. I believe we have all the working group feedback into the draft. And so I would ask the chair to get a sense of the room if he thinks it's appropriate, whether it's time for working group last call.
Okay, I would first recognize Marco Prorock if he still wants to.
Yeah, I was just going to state that I think any of the concerns I had with going to last call were resolved based on the work done between the last meeting and this. So very happy to see that work by both the authors on the spec.
Okay, then yes, let's have a vote that will also confirm on the mailing list if people feel that this draft is ready for working group last call. So let me use the tool.
Thank you. Anybody else want to join the queue, or should we move to the next presentation? All right, we will, thank you, Tobias. We will now move to the CBOR encoded certificate presentation. Oh, great picture.
Right. That's from yesterday. So hello, everybody. I'm Göran Selander. I'm going to talk about the status of CBOR encoding of X509. Next slide, please. So this would be really quick. It's only one slide. We haven't done much since the last meeting. There is now version 5, which is just a minor update addressing one of Ilary's comments. And we have, in this meantime, we also got some good feedback from Derek Atkins, who has one implementation. And there are a few implementations around. One of them is available in the COSE working group GitHub repo. So we will hope to progress this a little bit faster now. One of the main contributors has just defended his PhD and has all the time in the world suddenly. Well, we'll see. Anyway, so that's sort of the plan here, to do a lot of work before the next meeting. We want to fix the to-dos. There is one main to-do, and that's regarding OCSP, whether we should include the specification of the seaborne encoding of that in the draft or move it to a separate draft. So, which is misspelled, I see here. And the second point is to address the issues which are mainly comments from Ilary, but there are some other comments as well. So I think we are in a good shape. More reviews are, of course, very welcome. So anyone that's wants to try out the implementation or just make a review, that would be great. Thank you. Any questions or comments?
All right. Thank you. We're going to now move to one of the other active pieces of work in the working group, the COSE HPKE, which will be remotely presented.
Mike, I hope you can hear me.
We can. Thank you, Hannes.
Okay, cool. Excellent.
We can also see you.
Okay, cool. Technology works. Yeah, so this is a short update on version 4 of the COSE HPKE document. Next slide. There was so we had 2 new versions published since the IETF meeting in London. The first one, 03, which was in development for some time because we had a lot of mailing list discussions, feedback from Ilary, Daisuke, and many others on Mike and Ori, etc. And so I prepared the draft in the working group GitHub repository, and it led to a change in terms of the way how we represent the encapsulated key. Relates a little bit to the discussion we had earlier about the key representation. In the end, it turned out to be an array with the chem, the KDF, the AAD, and the encapsulated key as parameters. And that was in 03. And that also allowed us to delegate the registration of the algorithms or to reuse them from the HPKE IANA registry. So we didn't have to create our own registry for those parameters or create the mapping, which was in the previous version. We also then registered instead to one algorithm, which is the HPKE version 1 in base mode, and this mentioned encapsulated key header parameter. Then, shortly before the deadline, I shipped another version, 04, based on further feedback on the mailing list, mostly smaller changes and clarifications. One was to change the name of the encapsulated key to sender info, which will again be changed to HPKE sender info in the next version of the document, maybe to help to, or it will help to provide some clarity. More important, I think, is are the clarifications regarding the additional authenticated data. And I have a sort of a short summary slide at the end of this deck in case you haven't followed the discussions or read the latest version of the document. And version 04 served as a foundation for the hackathon this weekend. Next slide. Okay. Yeah, so 3 people participated at the hackathon, which was Lawrence with his DCOSE implementation, Daisuke, he's probably in the room, or hope so. He has a Python implementation of the CWT, and myself. And so we managed to get the two-layer structure from version 04 document working, and basically created in the DCOSE library and verified in Daisuke's library, except as stated here for one parameter, which is currently an open issue, the info parameter for in the HBKE. And there's actually code available for you to look at. the DCOSE library is in C, sorry, and the other one is obviously in Python. Okay, next one. Next slide. I think it was a good use of the hackathon time to do this type of programming exercise. In the working group repository, there's a list of issues, open issues, and if you ignore the last one, which for which PRs already exist, it's smaller terminology updates to reflect what some people expressed on a mailing list. There are a few more important ones, and I'm briefly going to explain them. The first one is about the fact that HBKE has a couple of different modes, and the COSE HBKE document currently only supports one mode, namely the base mode. And so Lawrence is basically asking, shouldn't we register the other modes as well? Because sooner or later, someone is going to use them. The second one is in the document. Currently, it uses a sort of language to say that you have to use a digital signature on top of what HBKE provides as encryption, and that's different to how other COSE specifications handle sort of or provide the way of writing. And so he suggested to, although it may be a common use case, to actually combine the two. He suggests to make it a less normative relationship, which kind of makes sense to me because that's the case how it's done elsewhere. So yeah, there is the AAD question, which I have on the next slide, and the use of HBKE for COSE Mac. Currently, it doesn't talk about Mac usage at all, but you can of course also create a key for a Mac algorithm if you want. So that was one proposal that has to be looked into, and the specification of the info value, which is an additional parameter besides the AAD into the HBKE functions, and the proposal is to use an empty string for that purpose. That's something that we will still have to incorporate. So there are a few open issues to look at and to further discuss. Next slide. And I would, it's a little bit an eye chart. So this slide, on the left side, you see the two-layer structure, an example of the two-layer structure, and with a one-layer structure example on the right-hand side. And you see that there are different AAD uses and also different info uses for the two cases. And what is maybe a little bit annoying is there are two places where the AAD value comes into the picture in the two-layer structure, namely once as part of the HBKE recipient, because that's a parameter to the HBKE functions. And there, in the latest version, we have some information for what to put into this AAD2 for the two-layer structure. And that's the issue I was just talking to, the infrastructure being an empty string. And then the the value for the AAD1, which is what is being applied to the actual encrypted data, to the encrypted plain text in that sense. So that's so there would be some more clarifications that need to be added here at this point. The one layer structure is a little bit simpler because we obviously have only one AAD and one info field, so that's less of a problem. So with those open issues, I think we made some progress over the last couple of months, but there's still further work to be done. I'm happy that there's some implementation work, and those implementations work together, at least right now. But yeah, I would appreciate feedback on some of the other open issues so we can close them and hopefully advance the document to a point where the working group is happy.
I invite people to join the queue. We have built-in substantial discussion time for this draft.
Yeah, maybe you can go back to the previous slide.
Okay.
So I personally, I think out of those open issues, probably the empty string for the info values, that's probably a good suggestion, and also the confidentiality without integrity, because it lines up to what we did elsewhere in COSE. Likewise, the HPKey for COSE Mac appears to be a low-hanging fruit and kind of makes sense to me. More tricky, in my opinion, is the HPKey for base mode. I haven't fully analyzed the extent of the changes, but Ori, go ahead.
I recognize Ori Steele.
Ori Steele. At lunch, Lawrence and I were talking about the auth mode versus the non-auth mode, and I wondered whether someone might just sort of provide some additional motivation for why we should go and define the auth mode now, or why we shouldn't because of other things happening within the draft. I like the idea of understanding more about that so that I could help more.
Yeah, I don't know if Lawrence is in the room because he made the proposal, and I asked him for motivation as well on that one. So yeah, I can't give you that motivation. But Lawrence is in the queue.
I recognize Lawrence.
So I don't have any particular use case for auth mode. It just seemed like a highly useful thing. I was kind of surprised that there wasn't anybody else doing anything with it. So, I mean, I don't think we need to hold up the draft for auth mode or anything like that. That seems like that would be a bad thing. But the one thing I would want is to be sure that we accommodate for doing auth mode at some point in the future, so we don't like the fact that this draft is now labeled as HPKE base mode, and any of the identifiers and values are allow for auth mode at sometime in the future. So if anybody has a use case for auth mode, I'm curious about that too myself.
Thank you.
Yeah, thanks.
I recognize Ori.
So I'm not an expert on HPKE, but in ECDHES, which is a non, there's ECDH1PU, and so perhaps there's someone in the room who has a use case for ECDH1PU who could speak to why that particular mode is exciting and why it would be good for us to have support for auth mode in HPKE. sooner.
Any other comments from participants? All right, I'm going to speak as chair for a moment, and I will close by requesting some help from some of you. Those of you familiar with the IETF process know that when you do a shepherd write-up for a document that you're trying to get to publication, one of the questions that's asked of the shepherd is, does the document reflect broad consensus of the working group, or is it a product of a small group within the working group? And quite frankly, if I was to have to do the shepherd write-up now, I wouldn't be sure how to answer that. I give Hannes a great deal of credit. Hannes, you've taken in a lot of input that's been fairly contradictory about, I don't think there's doubt that people want to do this work. I think there's been substantial controversy about the particular ways to do it, and I don't think that's been fully resolved yet. I think for the health of this work, it's time for me as chair to ask for maybe 3 or 4 volunteers to give the thing a thorough read, because Hannes has been doing the lion's share of this work. There's been a few of you who have been actively contributing, and I really do appreciate that. You're passionate about this. But I also see a lot of disagreement among the strong contributors about particulars. Therefore, I'm going to ask who would be willing, particularly if you're familiar with HPKE, to review this. Please identify yourself at the microphone for the note taker.
Yeah, this is Tim Hollowbeek. I'm willing to review the discussion.
Thank you. That is one. Are there others who care about? Can you put it in the chat? Can someone type Tim's full name into the chat? Hollenbeek, thank you. Is anybody else willing to do a review of the draft? Please go to the mic and announce yourselves.
Lawrence Lundblade.
I'm Daisuke Ajitami.
Thank you. Jessica, can you put your name into the chat? Thank you.
Carsten Bormann, you didn't say when you wanted to have this review done.
Kirsten asks when we would like the reviews. I think ideally within a month or so, maybe 6 weeks, but substantially enough before the following IETF meeting that we can have a full working group discussion based on the content of those reviews and help progress the work.
6 weeks I can do.
Thank you. Were you volunteering, Kirsten? Kirsten Borman also volunteers. Okay. As chair, I really appreciate this. It's when the working group really participates in work that it matures. And I appreciate all the individuals who've volunteered to do this work. Would anybody else like to say anything about the draft, or should we proceed to the next agenda item? All right, we will now move to the COSE-Key, JWK, HPKE, KEM discussion.
Hi, nice to meet you. I'm Daisuke Ajitomi. Nice to meet you. And I would like to talk. I'm from Toshiba, but I'm joining this meeting as an individual, and this is my first presentation at IETF, so I'm a little bit nervous.
Welcome.
Thank you very much. But I'll talk about this COSE-Key and JWK representation for HPKE Chem. Next slide, please. I want to skip this slide. Sorry, next slide, please. Yes, I would like to start with this basic HPK transaction. And as a prerequisite, the sender needs to know the recipient public key, and this kind of information such as chem identifier of the key and HPKE mode and KDF and AEAD identifiers supported by the recipient. And I will call this information, this key config information. And based on this key config information, the sender select a specific cipher suite, and encrypts this plain text with the specific cipher suite, and then sends the cipher text and along with the encapsulated key and the related things to the recipient. This is a HPKE sender information, which Hannes mentioned before, and finally the recipient receives the sender info and ciphertext and decrypts it. That is a basic HPK transaction. Next slide, please. So the scope of this, the COSE HPK draft is within this yellow line frame. Yeah. Next slide, please. Now, on the other hand, the scope of this proposal is this area. Next slide, please. So the key representation in this draft can be used for transmitting the recipient public key and the key config information, as well as for storing them as config data. In a typical use case, the recipient initially generates a key pair for the HPKE chem, and the public key generated at this time need to be shared with the sender in some way, along with the key config information. And I think the sharing this information through this kind of the .well-known slash data case endpoint is not a bad option. Particularly for web applications, I think it's user friendly because the web developers are familiar with this kind of a JSON-based format. In the context of something authentication and the authorization process. So, and on the other hand, the private key is used by the recipient to decrypt the cipher text. And at that time, the storing and loading this private key information in JWK format is also not a bad choice, I think. And yeah, so that is a typical use case, I think. Next slide, please. Yes, I think at this time, I understand it's a little bit, I understand it's not, how can I say it? How can I say it's a very early stage, but here are the details of my proposal, and this defines a new generic key type for HPKE named HPKE-CHEM, which can also represent a post-quantum CHEM keys and to be defined in the future. And it also defines its algorithm values like HPKE V1 base and but not. And additionally, this draft defines a new common key parameter named HKC for representing the HPKE key config information. And this HKC parameter contains these information like CHEM and KDF and EADs are supported by the recipient. The point is that these identifiers are 2-byte values registered in the HPK-ION registry. And this eliminates the need to define new key types and new algorithm values for future defined post-quantum chems in the COSE and HOSE world. And once registered in the HPK-ION registry, they can be immediately used in COSE, both COSE and HOSE, and without any additional work. Next slide, please. Here are the concrete examples of the key representation in this current draft. Left side shows JWK examples, and the right side shows COSE key examples. But it's this is just an early stage proposal. So next slide, please. Yes, I have received some great feedback from Ilari and Ori and Lawrence. Thank you very much. And there are some controversial points that they pointed out. First, whether the draft should be specialized for the COSE-Q representation. I think it would be better to define JWK representation at the same time in the same draft, but it's controversial. And second, the key type, whether this new key type, HPK can be accepted or not. I believe that it's reasonable to associate a key type KTY to the purpose of the key, but this approach completely different from existing key types such as EC and RSA. So yeah, and third point is whether to support existing key types, and the last point is whether to focus only on the HPK base model or not. Anyway, I believe these issues can be addressed after this draft is accepted as a working group document. Maybe. Next slide, please. This is the last slide. I know there are very many points to be discussed, but at least I think that this draft is necessary for. I think it's necessary for the set with the COSE HPK draft. So I would like to. I would be appreciated if you could consider adopting this draft as a working group draft. Thank you. That's all.
I recognize Ori Steele.
Ori Steele. I think this draft has been really, really helpful in highlighting the key representation dynamic with COSE HPKE. And I agree with the points of contention that you've outlined. And I think I also agree that they can be resolved by the working group if the document is adopted. I'm in support of resolving those contentious points as quickly as we can as a group. And your document and draft has a lot of really good ideas about how to reuse the IANA registries. I'd also be interested in how we might reuse some of the existing key representations from HOSE and COSE. I think we can find a way to fit this together as a group, and I'm grateful for the draft. Thank you.
Thank you.
I recognize Lawrence.
Yeah, I think that we need a key representation for the keys for HPKE, so I'm supportive of adoption of this draft. I'd like to see the draft focus solely on COSE key as a thing, and that to somewhat the exclusion of the negotiation. In RFC 9052, COSE key is a key representation. It is not a algorithm, a negotiation between a client and a server, or a sender and a receiver. So I'd like to see the focus just on a COSE key representation and the full use of how COSE keys are used, whether they're in databases or they get stuck in other protocols or all kinds of other things. I mean, I think the COSE key uses are, broad and not narrowed to one particular interaction or anything like that. And then, so it needs to honor like all the other stuff that's in COSE key, like how the algorithm parameter works in a COSE key. That wasn't discussed here, but I think that is a critical part of what this work should be to align with 9052. Thank you.
Thank you.
I recognize Mike Prorock.
Believe like Lawrence, and I think Ori was possibly going at this. I'm a big fan of the reuse that I've seen so far in this draft. While there's still work to be done, this is a complicated new thing. I think that doing that work within the working group would be very appropriate, and I would be highly supportive of bringing this work into the working group. So I really appreciate the hard work on this because it's
Thank
not
you.
easy.
Thank you.
I'd like to get a sense of how many people have read the draft. In the room, I see 1, 2, 3, 4 sets of hands. If any of those of you who are remote have read it, actually, I'll ask this of everyone. Those of you who have read it, please say so in the chat, whether you are local or remote. So we have 4 readers, which is decent. We have several people advocating doing the work in the working group. Does anyone want to speak against doing this work in the working group? All right, hearing none, the chairs will put a call for adoption on the list. I do encourage those of you who have read it or who are willing to read it to post reviews to the list at this point. Thank you for your presentation. Okay.
Thank you.
With that, we will go to our next presentation. Which is the COSE header parameter for RFC 3161 timestamp tokens.
Hi, this is Hank. And oh, there's my monitor. Yeah, hi. This is a relatively short presentation. Ignore the H at the org there. I think everybody knows that was wrong. Maybe you're familiar with RFC 3161. It's relatively old. When you need a trusted time source, you can set up a corresponding timestamp authority that typically has a clock that you trust, and then you can request a trusted timestamp token. That's been there for a while, and the return structure has a certain encoding. It is not CBOR, it's DIR encoded as the specific structure in DIR that is described in the RFC. And while we are doing the epoch marker as an update to that in the REDS working group currently, we need something now that can do the same thing, basically represent a timestamp token in a COSE header. So this draft basically proposes to define that. We actually did not propose a name for that header parameter yet, but the value is pretty much straightforward. It's the return value from the protocol defined in RFC 3161, which is a timestamp token in bytes. So next slide, please. I was highlighting this is a really short presentation. If you know how remote timestamp requests work, and if you understand how that is useful, we would like to ask this working group to work on that. Maybe give it a name, maybe define some of the security considerations around that.
Thank you, Hank. I recognize Karsten Bormann.
Thank you. I just want to make one very small point here, but I think that is important. So when we defined CBOR, we were trying to make sure that we could include other formats easily in the form of byte strings, that you don't have to escape them or anything. you can just throw them in. And when we defined COSE, we decided we want to embrace X509 as one format to move things around. So I think this is just a very logical thing to do. This is the thing we do in CBOR and in COSE, to embrace formats that are out there and excuse me, where you might find infrastructure that generates those timestamp tokens for you now. It's really useful to have that. So I'm very much in favor of this work.
Thank you.
I recognize Mike Prorock.
I am extremely in favor of this work. It is a very natural extension of things that are implied by many of the things that we are doing and that are being done elsewhere in IETF. I am also happy to help write security considerations for this document. So,
thank you. Yeah, that is, if there's no other comments.
I will ask the same questions that I did before. Who has read the document? I see 4 hands in the room, which was the same number as before. Can you please add your names to the chat so that your reading of it can be included in the minutes? I would request that you send reviews to the list. Does anyone want to speak against adoption of this document? Hearing none, the chairs will send a call for adoption to the mailing list. Thank you, Hank.
Yeah, and thank you, Mike.
Now we welcome Ori Steele to talk about Merkle tree proofs. And I have a request in the meantime to my co-chair, Ivo. I'm not sure that the additional presentations that were submitted have been uploaded into the meeting materials. Could you try to do that so that when we get to the AOB time slot, I will be able to present those? Thank you, Ivo.
They should be there. Maybe you need to refresh something, otherwise I can share them.
Okay. Thank you. Ori.
Apologies to the chairs for my last minute shameful slide submissions. So this, I'm here to present on a concise encoding of signed Merkle tree proofs. This is a very new draft, and it is about representing Merkle tree, Merkle proof data structures in CBOR and securing them with COSE. Next slide. There we go. So what does it do? It describes Merkle proof data structures in CBOR. This is the main challenge here is about this issue of Merkle tree agility. Merkle trees are a simple structure, and yet sadly, there's been a lot of different ways in which the leaf members are constructed, and that affects the structure of the whole tree. And so having some way to signal what kind of Merkle tree is this is really important, and having a compact and concise representation of that is also important. Another important component is using the existing signing libraries that we have today to be able to sign a Merkle root. This enables the concept of inclusion proof, and there's a lot of applications of signed Merkle roots, and they act as a kind of countersignature. I say kind of countersignature because you may be aware of previous discussions that we have had about the relationship between Merkle proofs and countersignatures. And I want to be clear, this draft describes just using a traditional COSE sign one structure to secure a Merkle root. And the one other point, to make about Merkle proofs is that Merkle trees are an important building block for transparency logs and other verifiable data structures. Anywhere where you have really high integrity requirements for your software applications, you might see the application of Merkle trees and Merkle proofs. Next slide. So why do it? Well, as I mentioned before, there is a desire to express Merkle proofs and Merkle trees in a way that's interoperable and that's supportive of the systems that have already arisen around the adoption of Merkle trees as a fundamental data structure. So CBOR inclusion proofs are very compact, and that alone is a great reason to consider working on this because there are representations of Merkle proofs out there that are far less compact and are wasting lots of space. Another consideration is the support for offline verification. COSE signatures over inclusion proofs can enable support for that when combined with other schemes. This is an important sort of valuable building block, as I mentioned. I'm also a participant in the SCIT working group and other working groups at IETF, and Merkle proofs are a valuable building block for some of those work items. And we'd like to be able to describe Merkle proofs in a way that is valuable to anyone who's using COSE and working with CBOR. And just, you know, on the subject of this transparency, I'm going to read the last bullet point first before the second to last one. There are transparency use cases out there, such as key transparency and certificate transparency. You may be aware of these use cases. I think key transparency has a BOF later this week. Certificate transparency has an RFC. And these are cases where a Merkle data structure is already in play, and the more people, the easier it is for people to verify these inclusion proofs, the higher the value of the transparency feature. And so having the ability to verify Merkle proofs based on libraries that are already widely available that are supporting CBOR and COSE is a way to boost the property of transparency, which is an important property for building secure systems, trustworthy systems. Next slide. So the status, I mentioned it's very, very early draft. It's filled with to-dos. There's lots of examples that we probably would want to remove eventually. The primary first challenge that we encountered in the document was around how to address this tree agility issue. So we know there's multiple different tree algorithms for constructing Merkle trees out there, and those each lead to details around how to verify a Merkle proof in that given tree algorithm. And so we wanted to find a way to express that in a basic system first, and we have that in the current draft, but it's very very new, as I said. Also, the terminology. There's a lot of potential for confusion around Merkle proofs because the tree structure is authenticated through hashing, but a signed Merkle root is authenticated through digital signature. So if I say proof, which one am I referring to? Am I referring to the inclusion path, or am I referring to the fact that the root is signed? So terminology, it can be really helpful here to provide better clarity, and the draft needs tightening of its terminology. The other consideration is the representation of the inclusion proofs. There's different representations in the wild. Some representations come from the tree algorithm, and some tree algorithms can support multiple representations. The current document contains several different examples. We'd like to reduce that to only the examples that are useful, and ideally one representation in CBOR for each tree algorithm, not several representations for the same tree algorithm. And we need better CDDL in the draft as well. Next slide. So this is an application example, but it's one that I'm very familiar with because it's related to the SCIT work, which is about securing software supply chains, integrity, and trust. And in those scenarios, what we want to do is we want to take a COSE sign 1 signed statement in, and we want to produce a receipt, which is a signed inclusion proof that that signed statement has been included in a transparency log. And that structure, it's a COSE sign 1 structure, this receipt, it's a COSE sign 1 structure. You can see here, there's this some header parameters that are familiar, especially with the presentations you've seen earlier today. So the ISS field in the protected header, key ID field in the protected header, algorithm in the protected header. But you see tree algorithm here. This is a new one. And this is the primary sort of contentious issue associated with the work so far. And then the inclusion proof structure, and this is just one inclusion path representation. There's this extra data and the hashes. The extra data has to get combined with the payload that you're going to secure. And then that becomes the leaf. And then that leaf combined with the hashes is assembled into a Merkle root. And that's how you know that that payload was included in that signed Merkle root. The payload of the COSE sign 1 structure is the Merkle root. One other comment is just to note about detached signatures. The payload can be detached, and then you can have safer APIs where you recompute the Merkle root first before you verify the signature. And then the counter argument to that is, well, if recomputing the Merkle root is an expensive, computational operation, maybe I would rather verify the signature first and then recompute the root and compare. So there's different ways to verify Merkle proofs or signed Merkle proofs. And that's work that we are describing in the draft currently, and we want to continue to refine that work. And finally, the bottom point, we hope to establish a registry for tree algorithms. So this is the main thing that we wanted to get to a sort of stable state before presenting to you all in the working group. You can see under the tree algorithms, there's some specific examples of sort of vendor specific products out there. And then there's representations of tree algorithms that have gone to RFC, such as the algorithms used in the certificate transparency work. And we think that a registry for tree algorithms will work well for defining the algorithms that are observed in the wild and they're popular. And it'll give us a nice compact representation for signaling what kind of Merkle proof was used. And we think that that's a good approach. Also, registries seem to be pretty popular at IETF. I think this is my last slide.
It is not.
Next steps. So as I mentioned before, how to handle the tree agility problem, registries. But with this extra caveat that some of these tree algorithms have a sort of vendor or application specific nature to them. We want to assign them a value so that you know what type it is so that you can recompute and verify Merkle proofs for it. We've identified several of these in the wild beyond the representation that's used in certificate transparency. And we want to be supportive of a single COSE representation for the family of Merkle proofs that arise from a compact and concise representation for Merkle proofs. So we think the tree agility issue should be solved before a call for adoption. And we propose a registry as a solution to this problem based on the feedback we've gathered from folks we've been discussing. But this is potentially a point of contention, and so would welcome any thoughts you have on the subject. I'm willing to offer alternatives that have been shot down, in flames, if your suggestions, well, if you don't like registries.
Karsten Bormann.
I don't like registries, but I think they are still the best way to do what you are trying to do here. So this just calls for a registry with a specification required policy, because you cannot capture all the specifics of all these different algorithms out there with one coordinate system. That doesn't work. So you have to have the vendor describe their algorithm, and then code point can be designed, and we are all happy.
I recognize Russ Housley.
Russ Housley. So I'm supportive of figuring out how to do this. And I think there's a difference between understanding what algorithm a particular log is using and which instance of a log that is using a particular algorithm. And I think you need to know both. And I only see one name.
Yes, so I completely agree. And what you're referring to is identifier or signaling mechanism, potentially in a protected header for a specific service in operation that maintains a particular log. And there are, that is something we talk a lot about within the SCIT working group. I want to be clear, some of the ideas that we're talking about here in this draft, we were first talking about in the context of SCIT, and we came up with some proposals and solutions that we presented at previous IETFs that have led us to this approach of trying to pull the generic components that are specific to, or pull the generic value of Merkle data structures into a document that would benefit everyone. It sounds like what I'm hearing you say is that there is some identifier that you'd like to see for the log system. And there's just one comment I would make about that is there are applications of signed Merkle proofs where there isn't a data, like there's no database, there's no service, but you're still going to use the inclusion proofs to create a selective disclosure scheme or as part of a single message. And so the idea of a mandatory header parameter for a service identity, maybe I would challenge,
Sure.
but certainly for the database applications, I think that's absolutely excellent.
That's all about.
Okay, wearing my chair hat, this is probably new enough. I'm assuming most people have not read it. I'm looking for volunteers from people to read it. And secondly, please put your name in the chat so it can be recorded if anybody is willing to read. I'd also like to ask a question that I'd like responses to in the chat, which is, who is aware of or has use cases for a COSE representation of Merkle proofs? Maybe we can connect your use cases that the authors may not be aware of to further the discussion. With that, thank you, Ori.
Thank you.
We will go to our last pre-scheduled presentation now, which is COSE profiles.
Ori is about my height. And it doesn't go anywhere. Hi, this is Hank. This presentation is called COSE Profiles. That's a very powerful title, I fear. Due to that reason, this is a hello presentation. Hello, we are starting to create a solution for COSE profiling. And next slide, please. Because we have the obvious first observation that COSE provides a pretty big bouquet of options that you want to use in certain scenarios. All these options then have to be selected correctly if you want to interop between two parties that use COSE. Maybe bidirectional, maybe unidirectional, but rarely everything that COSE is provided, I assume, is used at once. So you're always using specific subsets in specific ways. Next slide, please. And then the obvious, I think obvious, second observation is that there's no cohesive primitive how to actually identify these specific COSE messages in the end. You can do tagging, of course, and append that tag, but obviously that is outside the COSE envelope. And if stripped, you are left with, I have to check again, and does this really work? And that is kind of becoming a problem the more we use COSE. And I think COSE is way more than a rounding error today. that's a personal observation 2.1 or something. And going to the next slide, what we actually want to do is to describe what's this cozy thing that I'm producing, and for the receiver to understand that. Sounds super simple, but as we know, we now talked today about a lot of options, header parameters to put in there, all these values. I heard CWTs as values. There might be some complexity in actually defining that cozy thing and how to express that in the end. And of course, how to express that in a way that we're still retaining the security that is intended in the first place. Next slide, please. So obviously, we're starting with a header parameter that we are calling profile at the moment. And already that header parameter, we as a, I think, to give a scope to the problem, we provided with a type choice of certain values. The obvious choice is that every cozy use composition, the profile, is somehow specified and registered, because we all love registries, right? And then some organizations and some individuals already have identifiers in the world, like OIDs, and you could use them to identify a profile or the use of specific cozy configurations, I want to call them. You can also use URIs or concise resource identifiers. And I think potentially, again, this is a starter set for examples. You could do a UUID. So there's a lot of options here, and all of them have applicability. All of them came as a request when we talk to people. And this is just our very first thing. And only putting a profile tag into the header, protected header, of course, is not enough. You have to define and constrain or augment something. And there are rules how to create profiles. And because this is a hello presentation, we are not going into these rules right now, but they are listed in the draft that is in the title of the slide. Next slide, please. And we would ask the working group to think about what we already know, where this is related. So there's the Josie TYP. We also have media type serving in the function. I was talking about CBOT tags. EAT has a profile that is already used or in use in specification. And so there are similar things there that are not quite doing what we want to do here on the generic level. So if you have experience with that, please read the draft and contribute to it, because the next slide is the really next step we have to do. We really have to think about this and do it right. This is why we are not going to all the musts and shoulds, and why we actually have CDDL examples, and there's everything in there. And we need test vectors to understand, is this an actual instance of my profile? There has to be a lot of things to be done. This is our hello. We will ask certain questions on the email list. And I already see 4 people in the queue, and I think I will stop here.
So I'll speak as an individual. One possible adjacency is that there's the ACE working group, authentication and authorization for constrained environments, that many of you are involved in, that also has a profile parameter for, I believe, profiles of the ACE OAuth profile. With that, I'll recognize Karsten Bormann.
Thank you. Yeah, I think the ACE profiles are like these really complicated things that you write RFCs for to define them. And I sense these profiles are a little bit more on the side of feature sets, but maybe I'm wrong. So that's why I'm asking. So I think the word profile is about the worst word you could choose for this. But that's okay, because as long as we are trying to find out what it actually is, we might use profile as an identifier we all agree we are not going to use. Okay, but I think the main acid test question is, if the profile gets lost, or I don't understand the profile as a recipient, does the COSE data item still mean the same?
If you are implying content that you must know to process, no, of course not. If you can omit vital data by exchanging it with a profile identifier, but cannot look that up, what that means, then your message basically is dangerous now.
Yeah, okay, but that's an error condition that I easily can recognize. I mean, if I get a COSE with an algorithm identifier I don't know, then I cannot operate on it.
Yeah.
So that's not my question. The question is, does it actually change something?
So I'm going to close queue on this because we're at time.
Yeah.
I'm going to recognize, you two can talk some more, but I'm going to recognize Lawrence quickly and then Mike Prorock quickly.
I wondered if, when I saw this, if this has anything to do with negotiation of algorithms or something like that between two parties. That seems like an open thing here in COSE, and I kind of wondered if that was part of this or not, or if it should be.
I wouldn't open that can of worms yet. If this becomes stable and better understood after some steaming consideration sessions, working sessions, I'd say we can revisit that question. Potentially, this is perceivable, I would say. I would leave it at that.
Mike Prorock.
I don't think this is a unique problem to COSE, nor to other things that folks like this in the working group work on, either in this group or elsewhere. What concerns me is it might be one of those things where we open it up and then all of a sudden we find that we have opened up all of the oceans of the world and tried to dump them into one thing. Now, setting aside a parameter that identifies what a profile is and some basic well-bounded things around this could be an extremely useful thing. I'm thinking specifically of work that Ori and I are doing in physical traceability and things like that. We're being able to cleanly identify, here's this expectation we have. You go here to go look it up. That could be really useful, but we would have to really, really bound this. If we're not very careful about the scope of this item, I would have very strong concerns about it.
Thank you.
Right.
I will just comment on this quickly. Thank you. Exactly. We have a section. I always call them the rules. Look at them, please. If you see something that is harmful or dangerous to you or anybody else, I think we need a comment on that.
All right, thank you, Hank. With this, I will turn it over to Michael Richardson.
Hi, thank you for the last minute addition. Hoping that you can hear me. So next slide. So over in the ANIMA working group, we have a constrained voucher that's encoded in CBOR signed with COSE. This goes back, I don't know, maybe to 2018. We're finally getting to publishing it. It looks a little bit like this. There's a cosign 1, there's some stuff. And then in red, we have some content that is the Yang serialized using a document called Yang Sin, which is currently still in the core working group for another, I don't know, 10 minutes, I hope. And we call this application voucher - COSE plus CBOR. And at the time, that was sort of not really controversial. Next slide, please. Meanwhile, in the RATS working group, they have a thing that, well, it has some CDDL markup here, so it looks a little bit more impressive. But the red part is essentially a set of claims that come out of the COT work. And, so it's basically, it's shown expanded in CBOR, but of course it's actually just a CBOR encoded blob, which is signed for the whole thing. But there are claims that come from the COT registry. So there's not really, in some ways, very much difference between the two. They're both, they even have the same tag at the beginning, and it's a COSE signed thing. And obviously they are different media. One's an EAT and one's a voucher. But you notice that it says plus COT and versus it says plus CBOR COSE. So next slide. So the question is really, why are we using COSE plus CBOR? Or maybe we should be using CBOR plus COSE. I don't know. Would anyone be upset if we called it COT? Is there any material difference why we're making this differently? What should we do? Does anyone care? And it just seems like there's sort of a bit needless multiplication of media types. Obviously, we have, in the COAP space, we have our own content formats, and they would always be different. So I'm really asking, it's almost an administrative question. Why are we doing this slightly differently? And is there any advice? Did we do it wrong, or should we just go on our ways? There's no commonality. Carsten, I knew you had an opinion.
I recognize Karsten Bormann.
So a media type identifier gives you one class. A media type identifier that has a structured suffix something called SSS, I've always said what the something is, gives you two classes. The full media type is a class, and it gives you a superclass, which is the something like CBOR or JSON or whatever. And the idea is that you can do processing on the superclass if you don't understand the whole thing. Now, to create a plus CWT, the thing that is in that superclass CWT needs to be a CWT. And your voucher example isn't.
Right.
So you shouldn't use it plus CWT.
Fair enough. So would you agree that CWT COT is also a subclass of COSE plus CBOR?
Well, I don't know what COSE plus CBOR is.
Well, that's the question. Does anyone, and is it even useful to say, well, it's a COSE signed piece of CBOR where the payload is CBOR. But,
yeah,
and
now
so COT fits into that space.
Now you run into all these problems when you need multiple inheritance in a class hierarchy. And
right.
Wisely, people have chosen not to solve that problem. So It's essentially arbitrary what we do here. We just shouldn't do things that are wrong. So calling a voucher that has Yang CBOR in it and not CBOR claim, not a CWT claim set, plus CWT, that would be wrong.
Well, we could call it plus, something that said it was Yang.
Yes, and that's probably
right.
a structured syntax suffix. I remember the third word, structured syntax suffix that we should register at some point.
So you think we should use that?
Steele.
Okay.
Or Steele. So a couple comments. Whether or not you should use plus CWT, you can't right now. There's been discussion about giving people the ability to use plus CWT on the lists. And one of the primary drivers for some of that discussion is the JWT best current practices document, which advises you to basically, as much as possible, provide a more precise type TYP value than just JWT. And there's good reasons in the JWT best practices guide around why you should do that. And So those same reasons in my mind also apply to CWTs directly. On the subject of media types, I'd like to call out that there is a draft that's was about to go to working group last call and then didn't go to work. Well, I don't know exactly where it is, but it is in the media man working group. And in that draft, they discuss multiple suffixes. So where you have more than one plus sign in the media type and the interpretation of that. And yes, it does lead to a sort of kind of multiple inheritance scenarios. And I think the last comment is about whether you end with COSE or you end with CWT, or if you have CBOR plus COSE plus CWT, and you're using that new draft, that draft invites thinking about CBOR plus COSE plus CWT in a way that I think we should all be thinking about, because if that draft completes and we're thinking about media types as being an important component of profiling, people will read that draft and then they will bring that to the profiling discussion. One other thought regarding media types is the parameterization beyond just the suffix. So you may have seen media types like application LD plus JSON with profile equal to a URL, and the profile media type parameter is used to profile that media type with a suffix. So yeah.
Okay, I recognize Tobias, and then we're going to close because we're at time.
Yeah, my general feedback would be, if you don't have any intention to use any of the claims registered in the CWT registry or follow any of the processing rules, and the only relationship that your structure has that is similar to a JWT is that they're both COSE where the payload is CBOR, then they are sufficiently different. Because if you do use the CWT like identifier, you are then also bound to the extensibility rules that say to CWT, like, using and extending with claims that aren't going to collide with the registry or break processing expectations. So if there's no intention to use any of those defined claims, I think it would be safe to pursue a different media type. And in terms of COSE versus CBOR, I don't have a massive opinion on that particular aspect.
Okay. Speaking as an individual, I believe that for the same reason that we registered plus JWT in the JOT best practices BCP, some drafts should register plus CWT. And in general, we want to use the most specific typing for objects as possible for the security reasons listed in the BCP.
So my take home is that.
Go ahead.
My take home is that I don't know why we have a dash and not a plus. And it's a question, but my take home is that we should actually have a media type for Yang encoded SID in CBOR that is more specific, and whether or not we should have a CBOR plus COSE as a type, as a higher level superclass, whether that's ever meaningful is a discussion we should have on the list.
On which list?
On COSE, and I heard Media Man. I guess I'm not on that list.
Okay. All right. Wearing my chair hat, if you have not joined the Meet Echo, your attendance is not recorded unless you also went and scanned the QR code. If you're here and you did not join, please scan the QR code. Thank you all for a very productive session. I appreciate all the work that people put into it. Thank you, Ivo, for helping me chair.
I hear you can't run
The QR code is also now available in the front of the room.